Hello guys, this is the third video in the JavaScript playlist. In the first video, we saw how to build a basic JavaScript website and what are the various basic fundamentals of JavaScript. In the next video, we saw a lot about variables. So I went really deep in variables. I told you about let, const, and var keywords and what is lexical scoping. And finally, we ended the video with closures. This is the third video in which I like to start with functions. Okay, functions also will go very deep in functions so that you know what are anonymous functions, what are default values, what are higher order functions, what is first class functions and all. So I'll go deeper than normally what people go. And let us have only functions in this particular video, and henceforth all the videos will be topic specific. Like the next video could be on arrays, next video could be on strings. So I haven't thought so much, but I've already prepared 200 plus slides, and we'll go step by step. This video only functions. So let us see what are functions. There are two things in a function. One is declaring a function, and second thing is using that function. That means calling that function. Function declaration is also called as function definition, and this is how it is done. Either you can write function add and then you give the definition of that function, or you can say that this is an anonymous function and I am assigning it to a variable. This variable can be a let variable, var variable, or const variable. Okay, or the third and the more modern way of doing it is the same thing, that you assign the function to a variable, but this function is defined using arrow operator. Arrow operator means equal to sign followed by greater than sign. So it basically forms an arrow like structure. So this is called as the arrow operator. So arrow operators are used because here you would be writing function so and so. So instead of writing the function keyword, you're just writing an arrow over here. Okay, now what difference does it make? You might say it's just syntactical sugar. Yeah, it is syntactical sugar. At the moment, you just remember this much, that it is easier to write the functions that way. In the latter videos, I might tell you what are the real advantages, but at the moment you can think of all these three as just the ways of declaring a function, and this is an easier way of declaring a function. Okay, so all these are function declarations, but this last one is function call. Okay, so here you're calling the function, so this is called as a function call. Now, what are arguments and what are parameters? Many people use them interchangeably, but there is a difference. Here, if you see the same example again, here while declaring any function, we write num1 and num2. So this is what? These are not the actual parameters. These are just the arguments. Means for argument's sake, let us imagine that the first number that is passed is num1 and the second number that is passed is num2. So just for the argument's sake, let's imagine that the first number is number 1 and second number is number 2. So just for the argument's sake, got the idea? That's why they are called as arguments. Okay, and here these are the actual parameters based on which we are calculating the results. So these are 2 and 3 are actual parameters passed to number add, and accordingly the result will be calculated. So these are parameters. Okay, arguments, parameters. Then what are first class functions? Actually, very few languages in the world treat functions like variables, and JavaScript is one of those languages, and that's why JavaScript is said to be a language having first class functions. Means what? The functions in JavaScript are first class citizens, you can say. Like it is often said about America that XYZ community is the first class citizens of America. The police won't catch them. They have the privilege. They are the privileged class. So first class citizens. Likewise, functions are first class data types, you can say, in JavaScript. And alternatively, you can also say that JavaScript has first class functions. Okay. Now, there are many such languages, just like JavaScript having first class functions, Perl, Python, PHP, etc., etc. So all of them have first class functions. Such languages support two things. One is you can pass a function as a parameter to another function, and second is you can return a function as a return value of another function. Got the idea? So when you consider function as a variable, then just like you can pass a variable inside a function, you can pass a function also inside a function, right? And just like you can return a variable from a function, you can also return a function from another function, right? So this is what first languages having first class function support do. Higher order functions. So higher order functions are those functions which either accept other functions as arguments or return another function as the return type. Okay. So here are a few examples I had given, leave them at the moment, but concentrate on the very last two examples. So here I will say that function name length. This function means get the length of a function. That is the purpose of this particular function. Okay, so here you will see that it is accepting a function as an argument, and so this function is a higher order function. Similarly, if you see return func, so it is returning another function, and that is why this can be called as a higher order function. So return func and function name length, these two are higher order functions. Whereas whichever function is passed to it, this new func is not a higher order function, because it is new func is neither accepting a function as an argument, nor is it returning a function as an argument. So new func is not a you can say higher order function. Similarly, original func is also not a higher order function. Okay, so this is what I've tried to highlight in this slide. Said that these two, function name length and return func, only these two are higher order functions. Now I do not know what title to give this slide, but there are a few nitty-gritty items that I really want to discuss about functions. So let us imagine that there is a function called as original func, and you're assigning that function to another constant, let us say new function. So there is another variable of type constant, means of declared using the keyword constant, and you're assigning this original func to new func. Okay, so this is very easily possible. There is no problem here. So now what will happen is, what is a function? Basically, function is just a memory location. Okay, and all these variables that are created inside the function, like even these arguments, they derive memory inside that memory which is allocated for that function. Okay, so that is what a function is, basically just a memory location. That memory location will also have a property called as name. Okay, so it is one memory location. Okay, now it is pointed by two variables. Variable 1 is original func, variable 2 is new func. Both of them are pointing towards the same memory location. Okay, but the memory location is the same, and only that memory location will have only one property called as name. So in name property, only one variable name can be stored, right? So when that memory location was created, it was created during this sentence, during this statement, you can say. So whenever this function was assigned to this variable, at that time that variable that variable's name got saved into that function's name property. Okay, so now when you say new func dot name, so new func is just a variable, it is pointing to certain function. Function means that memory location. In that memory location, there is only one property called as name. Which what value will that name property have? What do you think? It is not new func, it is the original func, because that memory was created while declaring the original func variable. Okay, and that's why here if you will see new func dot name, it is original func. So I just wanted to let you know that this is how it is. Now I don't know what name I should be giving to that slide, and that's why I clubbed everything like this into one slide. Another thing that I wanted to highlight upon is when you say new func or any function dot string, so it basically gives the entire definition of that particular function. So it consoles out the definition. Okay, so since I'm saying console.log and then new func.string, so new func.string will give you the entire body or entire declaration or entire statement of the function. Okay, then here what am I stressing upon? add our own ismath function. So here, let us say that this function is already declared. Now inside this function, let us say that I wanted another property called as ismathfunc. Okay, so how will I do that? So you can always add new properties to a function just by saying that function name dot and whatever property you want is equal to whatever value you want. It's very easy. So functions are not carved into stone. You can always modify their scope. You can always add new items to that function. Just like this, you can just say function name dot your property is equal to something. Similarly, if you want to add a function inside a function, you can say that new func dot inner function equal to, and you can give a definition of a function. So functions can be what can you say, expanded. Their scope can be expanded, their meaning can be expanded, their definition can be expanded even after they get created. Got the idea? So this is all that I really wanted to stress upon. I didn't know what title to give, so everything is coming into one slide. Let us see how to pass a function as an argument. Okay, so higher order functions can accept another function as a parameter. Sorry, not argument, parameter. You always pass parameters, not arguments. Okay, so here I have created two functions, f1 and f2. F2 function is accepting another function as a parameter. Okay, and this is how it accepts it. And you can always console out its body like this. So I have consoled out the body of that particular function over here, or you can also call that function from within this higher order function. Okay, so this is how it is done. Next example is how to return a function from a higher order function. So you can always return a function as a return type of another function, and it can also be invoked later. So this is how you do it. So let us see this example in more detail. I've just copied it over here, and I'll also show you the console. So this is what is consoling out. So here what we are doing is this is the outer function. We are basically calling the outer function over here. Okay, and this outer function is returning something. What is this? This is another function by the name inner. Okay, so now this inner function is getting returned over here. Okay, right? So when I say console.dir means, it means whatever is inside this, you just show it in the console, but not just in one liner. You show it as an object, and it should be an expandable object. So it will show it like this, and then I can expand it like this. Okay, and I can expand anything inside it just like this. So this is called as console.dir. Okay, directory outputting something. So this is directory outputting whatever is the return type of outer function on the console. Got the idea? Okay, now here what is the returned thing? The returned thing is this inner. Inner is what? It is a function. So this f is written there, so it's a function. And inside this you will notice that it has two scopes. One is the global scope, another is the closure scope. Okay, so global scope says that global scope means every object basically has a global scope. So even this function also has a global scope. Okay, but it also has a closure scope, which is outer. Outer means this particular function. So this scope is being returned along with inner. Okay, so one of the scopes that inner has is this closure scope. That means this outer function scope. Okay, but a point to be noticed here is it has a, b, but it does not have c variable. Why? Because this inner does not require c variable in the closure scope, because it's never calling it. So why to have that variable in the closure scope, right? So the closures are very intelligent. Closures keep only that data which is being used by that particular function. Okay, so I'll give you an example. Suppose if I start using c, then you'll notice here that the closure scope will now have variable c as well. And if I stop using b and c both, then closure scope will have only variable a. See, closure scope has only one variable, which is a. Okay, so basically here in this slide I wanted to explain two things. One is how to return a function from a higher order function. Here higher order function is outer function. Okay. And second thing that I wanted to highlight was this scope, closure scope. So closure scope has only those variables which are being used inside the function which is returned. Okay. So that's all. Let's go ahead. This is what I have also mentioned over here, that when you return a function, it is returned with its lexical scope, means only those variables which it uses. So A and B are a part of the inner lexical scope, but C wasn't used, so C is not a part of the inner lexical scope. Function along with its lexical scope is called as a closure. We saw this in our last video also, that what is closure? Closure is what? Closure is the returned function along with its lexical scope. So here, which function we are returning? We are returning inner function, right? So inner function along with its lexical scope is together called as closure. So whenever you return a function, you are actually returning a closure. You are not just returning inner. Inner comes along with its lexical scope. So you are always returning a closure, means function along with its lexical scope. That means closure. So you always return a closure. You never return a function alone. Okay. Now let's go through two more slides. What are default arguments? It's very easy, but I just wanted to keep it in the slide so that you don't forget. Whenever you say a certain argument is having certain value, what it means, its default value is 1. So when I say multiply 5 and if I give some value to b, then that value will be used. Okay. But if I just say multiply 5, I don't give a value to b, then the default value of b is 1. So it will be 5 multiplied by 1. So it will return 5. Got the idea? So these are called as default parameters. Okay. So b has a default value of 1. And then what are anonymous functions? I've already told you. Anonymous function means a function declared like this, wherein you don't give the name to that function. Another way of writing anonymous function could be to write an arrow function. See here, if I would say, I'll just say this much. Okay. This is outer function, right? If I don't give a name, it will become anonymous function. Similarly, if I don't write anything and if I just say here like this, then also it is an anonymous function. Okay, so these are two ways in which you define an anonymous function. Either you define it in the older way without giving any name, or you define it like this without giving it any name. Okay. Then yeah, this slide I forgot. Function statements, declarations, definitions are hoisted, but function expressions are not hoisted. Okay, there are two more slides. This is very important topic, and very few content creators speak about this. So purposely I've included this. Let's dive deep into functions, right? So function statement means function declaration means function definition. It's the same thing. Okay. What is function expression? So whenever you say that variable f to f4 equal to this function, then whenever you create a function and you assign it to a variable, then that is called as a function expression. Whereas here if you just create a function like this, then it is just called as a function statement or function declaration or function definition. Got the idea? See, if you just create a function like this, then this is function definition, also called as function statement or function declaration. Okay, so this is just the function definition. But if you write something like this, that let f1 equal to this, then this is function expression. Another way of writing a function expression is, instead of let, you can use const. Instead of const, you can use var. All these are function expressions. And you don't need to write an arrow function only. Even here, if you say let f2, I'll call it something else, is equal to something. So this is also a function expression. So, sorry. Function. Yeah, so I meant to say that if you write an anonymous function like this, then this is also, whenever you say equal to, then it becomes a function expression. this is also function expression. Whereas if you just write function f3 and then you write this, then it is a function declaration. So this is function declaration or statement or definition. Got the idea? And because you are not writing equal to sign over here, okay? And if you write an equal to sign, then it becomes a function expression. So this is a function expression, and this is also a function expression. Got the idea? This is the difference between function declaration, that is function statement, that is function definition, and function expression. Okay. Now, function, what does this slide say? It says that function declaration or function definitions get hoisted, but function expressions are never hoisted. So what this means is, if I try to call f3 over here, then I can easily call it. Okay, f3, okay, let me just console out something. Console.log. If I am saying f3, okay, so it is possible to do it. Okay, it doesn't throw an exception. But yeah, but if I try to use f2, before defining it, then it will throw me an exception. It will say that f2 cannot be used, cannot be accessed before its initialization. Okay, f2, it is treating it as a variable, and it says this variable is not initialized only, and you are trying to use that variable, right? So this is the problem. Similarly, if you say that if you say over here, then also it will give the same error. It will give you the error. See, f2 error is there, so let me just remove this error, then you will get the next error. Yeah, so the next error that we get is f1 is not a function. So here I'm using f1 like a function. It's not a function. Actually, what is the case? I'll tell you. f1 is a variable defined using keyword var. So var keywords, I had told you earlier also, var keywords are hoisted. So it got hoisted, but its value is not assigned to it. So only this much got hoisted, var f1, that's it. But var f1 equal to what? That is not hoisted. So initialization of that variable is not hoisted, and so it says that, oh, I don't even know what that variable is. I don't even know whether it is a function. And so how can you call it like a function? It's just a variable. Now let us say that here, if I say let, then it will again throw the same exception saying that you cannot use f1 unless you initialize it. Got the idea? So you cannot use a function expression. If a function is defined as an expression, then you cannot use it before declaration. Okay, if a function is defined as an expression, you cannot use it before declaration. But if a function is defined like a normal function, means function definition is there, but function expression is not there. So in the function definition itself, if you are giving the name, then this gets hoisted, and that's why you can always use it before its declaration. Okay, it could be a little complicated, leave it. I just wanted to dive deep into functions, that's why I included this slide. Another slide is what are named function expressions. This is not a very important slide, but we just wanted to dive deep into functions, right? That's why. So here, if there is a function called as func3, and I'm assigning it to this variable. Okay, so this is what, this is a named function expression. This is function expression because equal to sign is used. Okay, but it is a named function expression because this is a named function. It's not an anonymous function, it's a named function, and this expression is a function expression, right? See, fundamentally what it is, this is function expression. Sorry, this is function expression. Why? Because this is an anonymous function. Anonymous function, I'm assigning it to something, and that's why this whole thing becomes anonymous function expression, also called as simply function expression. But let us say that this function was already named as Amit Funk. Okay, so then it becomes a named function expression. Why? Because this function is not an anonymous function, it is a named function. And of course it's an expression because equal to sign is used, so this whole thing is called as named function expression. Got the idea? So named function expression. So f3 as well as func3 can be used inside the function. So here if I say console log f3, then also I get a result, and if I say console log func3, then also I get the result. Okay, but so let us see that. So here if I say I'm just calling out this particular function f3, and I'm calling the function using f3 as well as func3. So f3 returns, f3 basically calls this particular function properly. But if I say func3 from outside, then func3 it doesn't know. Okay, so here you cannot call it like this. It says that func3 is not defined. But I can very easily say that f3, call f3. So it understands f3, but it doesn't understand func3. So that is why I've written that f3 as well as func3 can be used inside this function. So inside I can use f3 as well as func3, but from outside this function I can only use this variable name. I cannot use func3. It's a funny way in which JavaScript behaves, and that's why I've included it. I don't think you'll be asked an interview question on this, because very few people even care to understand how JavaScript works, even the interviewers. So I don't think you'll be asked an interview on this, but you'll be asked a question in an interview. But it's an interesting thing, right? We are diving deep into functions. That's why I included it. So do let me know in the comment section how you like this video, and upcoming videos will be topic specific. Like this video I kept very topic specific, with only deep dived about functions, because even functions is a deep topic. So let's go deep into every topic. And in the video description of all of my videos you will see a PDF file. So that PDF file will have all the slides. It will have a watermark also, just like this Amit Shirasao you see in the background. That watermark is going to stay there. Okay, but you will still be able to copy this text using that PDF. So from that PDF you just try to copy this particular text, you will be able to copy it, and you paste it in the Visual Studio Code, it will run. Okay, so all this code is tried and tested by me, so definitely you will be able to run that. Okay, and see, for example, here if you want to make some modifications, you can always make to it, and you try it in the Visual Studio Code. That is more important. Don't just go by the slides. You copy this code, try to run it yourself. That will actually boost your confidence also, and it will also give you an insight about this particular language. See, any language in the world can be learned by practice. How did you learn a foreign language like English? You learned it by practicing, right? Your schools told you to use it again and again and again. Don't use your vernacular language inside the school premises. This is what most of the schools say. Why? Because we are not here to practice vernacular language. You have been put into the school so that your parents wanted you to learn the new foreign language, which is English, right? So you use it as often as possible, then you are able to gain expertise on it, then you are able to speak like a native speaker, right? Similarly, JavaScript, you have to use it. Don't just listen to me. Don't just see me show these slides. This is the code that I wrote. You write your own code. That will develop you. Looking at my code won't develop you. Try to practice it. Okay. And do let me know in the comment section if you need any help. I'm there to help. Okay. Until next time, Jai Shri Ram.
This is Amit Shirasao, and you're watching Coding.